The inventor Nikola Tesla dreamt of wireless power. Among his work in the realm of electricity, he built a coil, later named the Tesla coil, which could illuminate lamps from across a room and throw the occasional bolt of lightning at the nearest conductor. Tesla coils remain popular today, though often for their ability to put on a fantastic lightning show. Nikola Tesla believed in wireless power with such an enthusiasm that, with the financing of J.P. Morgan, he constructed a giant apparatus, the Wardenclyffe Tower, at his lab in Shoreham, Long Island in 1901. This was before the world was wired.
Way back then, when people were thinking about electricity and how people might use it, I don't think it ever occurred to them that people would string wires all over the country. Early on, people were thinking about transferring power wirelessly.
The idea? To send wireless power around the globe.
We love electricity so much. Human beings love it so much that we've been willing to put in wired power everywhere. I'm sure if you go back to Tesla's time, he wanted to do things wirelessly and experimented with it because he thought, who would be crazy enough to put in the trillions of dollars of infrastructure that we've put in?
More than a century after Tesla's tower, we're still tethered to the wall. Witricity, a startup in Watertown, Massachusetts, is one of several companies hoping to revive Tesla's dream, and it's doing so by developing a business in wireless power transfer.
There's power everywhere in the world except that last few feet from the wall to the center of the room. That is the last part to go wireless.
And once that last part goes wireless, this projector can receive its power from a source that's almost a meter below. Here's how it works. Run an electric current through a coil of copper wire, and the coil will produce a short-range magnetic field. Place a second coil within this field, and an electric current will flow through it. The magnetic field has transferred electrical power from one coil to the other. This principle is called induction, and it has been understood for more than a century. Induction is what charges a wireless electric toothbrush, for example, and it works well over extremely short distances. Pull the coils apart, and the power transfer ceases. It turns out that the trick to longer distance power transfer is the same principle an opera singer uses to shatter a wine glass from across the room. It's called resonance. For the opera singer, when the frequency of the sound wave matches the unique resonant frequency of a glass, the acoustic energy is converted to kinetic energy at the highest possible efficiency. The energy then builds inside the glass until it shatters. The coils that Witricity uses to transfer power wirelessly are magnetic resonators. First, a rapidly oscillating electric current is applied to a coil at its specific resonant frequency. This creates a magnetic field in the region around the coil. Tune a second coil to the same resonant frequency as the source, and it will couple, resonating anywhere within that region and converting the oscillating magnetic field into an electrical current within the second coil. This response is called highly coupled magnetic resonance, and it hasn't been done before. By attaching the second coil to a device, such as the battery of an electric car or a mobile phone, this current can be made to do useful work. The source can be either centimeters or meters away from the device being powered, and can deliver power through walls or around metal obstacles. The power can even be distributed across multiple devices at once. So by a simple trick of physics, power is transferred wirelessly. Nikola Tesla would be proud.
You could put these resonators in walls, in floors, in ceilings, and would allow you to power virtually anything in your house. You could place it under the counters. Imagine you could just go home and if you carry a purse, you throw your purse onto the counter, and you don't even have to think about taking your phone or your camera or your PDA out of your purse. It just charges because the surface underneath your counter is energized.
Witricity is developing a system, not a specific product, and as a result, they have many different platforms on display at once. In Witricity's demonstration rooms, a flat-screen television is powered using a resonator hidden in its base. Laptops, with their batteries removed and replaced by resonators, flicker on, and flashlights glow when placed next to a source concealed behind a bulletin board. The system can even be extended beyond the range of a single source, using passive resonators like this one. By this method, many cabinet lights are lit well beyond the expected range of the single source below.
Maybe no surprise, you get the light to come on even inside the cabinet, way up in the cabinet.
You can almost think of it as though the energy is held by the structure itself. We're not sending electricity through the air, and it doesn't radiate out into space. It's when another kind of a copper coil or wire coil comes in the vicinity of that field that it can sense it and then capture it and turn that magnetic field into a current. So safety is definitely one of the issues that people think about and ask us about. So one of the things that makes it very safe is the fact that we're using the magnetic field to transfer the power. Humans look almost like free space to a magnetic field. In addition to that, we have a lot of electronic devices that we use every day, and so there are well-established standards for what the fields around those devices can look like, and all the technology that we develop will conform to those same kind of standards.
The intensity the magnetic fields we're using, by the way, are about the same intensity as that of the Earth. Most people don't think of it, but the Earth we're in a magnetic field right now.
The applications of wireless power in a wired world are endless, and rethinking infrastructure may be decades away. A simple first step could be removing costly batteries from things as mundane as computer accessories, and instead placing a small wireless resonator in the computer itself, tackling waste by centimeters at first.
Because at the end of the day, if you can find something that is convenient for people and saves energy, that's the killer app.
Wireless power has in fact been available for decades, just waiting for a clever user to snatch it out of the air. It exists in radio and television signals and is available 24 hours a day. Josh Smith and a Lanson sample of Intel Labs in Seattle, Washington, are pointing their devices at television antennas and powering small but useful gadgets solely off of the energy that carries TV programs.
Well, there's energy all around us. TV signals, which you normally think of as just information, also have a little bit of energy content.
One of their projects is named WARP, and it stands for Wireless Ambient Radio Power. According to them, we are just entering the boom years of energy harvesting.
We're receiving energy from the TV towers that are 4 kilometers out that way. They're putting out a megawatt of power. This TV antenna picks up the radio signal, comes through this coax cable here, little rectifying circuit, turns the radio signal into regular DC voltage, just like a battery would put out. And right now it's powering this kitchen thermometer. So as we turn this away from the TV tower, at a certain point, it's going to lose power. Now it's off because it's not facing the TV tower. If we bring it back, pops back on as soon as it's got enough energy. So here's the TV tower, transmitting tower. Here, we're up here near the University of Washington. These circles show the amount of power you'd expect to be able to get as a function of distance. So kind of anywhere in the city of Seattle, you'd expect to be able to get up to 100 microwatts. Compared to solar, of course, solar is a really good energy harvesting source, but it's only available for 12 hours a day. TV is always there. TV towers have been broadcasting about the same amount of energy or power for decades, but what's changed recently is that the power requirements of the smallest devices have gotten low enough that you can actually power them off a TV tower now.
Josh Smith says wireless ambient radio power harvesting might yield a milliwatt or so to a device. That's not very much. It would require 20 milliwatts to keep a mobile phone in standby mode, but it might be enough to perform some useful low-power functions.
Doesn't sound like much, but that's actually a lot for sensors. You may not be able to make a cell phone call, but maybe you can press a 911 button that does nothing but sends this one very small but very important data packet. I think many consumer electronic devices will start to have a little kind of reptilian brain that perhaps never powers down, and perhaps that is being powered off of ambient RF signals. There's the annoying flashing VCR clock. I don't know if people have VCRs anymore, but so that may be another solution to the problem. But there's no reason why digital clocks in the future should ever run out of energy. I think if you wait a few years, it'll actually get really practical, and I don't see why you wouldn't see it all over the place.
It's amazing to think that there's so much energy just ambiently surrounding us, and the potential for us to actually harvest it, make use of it. This is arguably not the most useful thing ever, but I think the potential is really there to make some very user-friendly applications.
Nikola Tesla's tower was torn down in 1916. Mr. Morgan, his financier, was uninterested in broadcasting electricity that people could so easily harvest for free. Instead, we strung wires and built meters. Tesla knew that wireless power transfer was possible, but he never saw his dream realized. It seems that soon enough, we will.
The Economist.